The triangle we're really interested in is this one at the top, right? So even though there is a right angled triangle which sort of encapsulates it, this is the one I'm really looking at, which you can see is not right angled, okay? But you can use right angled triangle trig, which is really the trigonometry of all triangles, to get toward that triangle, right? So the simple question they pose for you is just find x, okay? This is interesting because there's an intermediate length. I have to work out this length down here. How do I work it out? What am I going to use? I'm going to use tan, aren't I? Right? Because I've got an angle here. I have its adjacent side known, and the opposite side is what's unknown, okay? So if I just sort of quickly label this as y, good morning, the equation that you would write is, well, tell me, what statement would you make about this triangle down here involving tan? Tell me what to write.
Tan 30.
Tan 30?
Y on 10.
Good. Opposite on adjacent, okay? Now, tan 30, that's an exact angle. 0, 30, 45, 60, and 90. You've got exact angles for all of them. And the quickest way, if you think back to a couple of weekly quizzes ago, the quickest way to remember what they are is just to draw up your triangles, okay? In fact, I'm going to encourage you, whenever you've got a test that's going to involve trigonometry, the first thing you should do is draw this pair of triangles, okay? You only need to know very, very little information in order to do these. If I make this a 30, 60, 90 triangle, okay, the easiest trig ratio, the easiest exact trig ratio to remember is sine 30, which is a half. Good. Sine 30 means opposite on hypotenuse, 1 on 2, right? And then by Pythagoras, or by memory, you can work out that that's root 3. Okay, so from there, I have all the ratios, sine, cos, and tan, for 30, 60, etc., right? This one down here is the same triangle but isosceles. So if I make this 1 and 1, that would make the hypotenuse root 2. And because it's isosceles, you've got these 45 angles here. Okay, yep.
Did they ever ask you to draw them any time?
No.
Because it was like in here and I didn't know how to do it.
Yeah, well, it's an exercise, so that's a bit different.
Sorry.
Good. Okay, so I always, like I mentally do this, there are some other tricks which I might show you throughout the course of our Drupal period to remember these, but I think this is probably the most efficient. It's not the most glamorous, but it works. Okay, so I'm after tan 30 in this case, right? Tan 30. So where's tan 30? There's 30, right? So opposite on adjacent. Yeah, happy with that? So that's going to be 1 on root 3, y on 10. Yep, so far so good. Okay. So now, just by taking that equation, all I need to say is multiply both sides by 10, and now I have this distance. Okay. So now where do I go? Oops. Where do I go from there?
Tan 60.
Okay, so now I've got the bigger triangle, right, which is an angle of 60 in there, and I'm going to make the same statement. Tan 60 is still opposite on adjacent, right? But this time I've got some actual lengths here. Okay? Yeah, looking good. So what's tan 60? Again, look at your triangles. Tan 60, tan 60. Have a look. Opposite on adjacent, right? Opposite on adjacent. So it's root 3 equals x plus 10 root 3. Now just to save myself a step, rather than write that 10 on the denominator, I'm just going to multiply across. I'm going to have to do it eventually anyhow. Yep. So now I've got x equals 10 root 3 minus 10 on root 3. Yep. Suggestion, what should I do next?
10.
I got a couple of different choices. I could rationalize first, right? Or, I don't know, for my head, I like to get one fraction first. You're going to get the same answer anyhow. So here I'm going to multiply by root 3 on root 3. Okay, so that gives me 30 on root 3. You happy with that? Minus 10 because I have the same denominator, don't I? Okay. So that gives me 20 on root 3, and now I'll just rationalize. Done. Okay. So up in this triangle here, if that's all I had, we can determine what this length is. And, just to play hypothetical, if I, took away this triangle down here, if I had this length, I could still work out what the length was.